So this is the second video for this unit on measuring and on looking at basic Euclidean geometry. So I want to talk about cube forms. I'm going to start by just drawing the one kind of cube base form. It's not a perfect cube, obviously, because it's taller, but it's based off of the structure of a perfect cube. Its top is a perfect square. So the fundamental question when drawing an object like this is figuring out what are the right angles. Like, what is this angle and what is that angle? And we'll talk about a couple of different ways that we can measure it. First thing we need to do is we need to make sure that we're right about the top. Because once we know we're right about the top, we'll then have a little bit of an easier time figuring out about the bottom. Okay, so one of the ways you can measure angles is you can hold a measuring tool up against the angles and test it. Tells me that's a little bit more steep than I thought. Tells me that this is a little more steep. So it appears that right off the bat, I am kind of beginning with an assumption of like this being closer to my eye level, that I actually see more of the top of this form than what I was expecting, which is actually different from what most of you are going to find. You're going to find that your errors are usually going to be the opposite, where you actually show too much of the form, or too much of the top compared to. Now I drew this line right there because I know that that particular line is going to be a useful measurement for me. It's a measurement in a couple of different ways. One is, where's this corner, how does it relate to that point right there? If I hold up, and so it's telling me that it actually should be a little bit more over there. So that could mean that the error is either on this back line, that back line, or both. Let's try fixing it by lowering that line slightly and lowering that line a good deal. And then let's test that decision by re-looking at these measurements of angle, seeing if they line up pretty well. They look like they line up pretty well. You guys took all my needle eraser.
You need an eraser?
Yeah, I need some for erasing. Thank you. I wasn't expecting them all to disappear. Okay, so once again, we could also, so we checked this back measurement in terms of where it lines up against that line. We could also check it in terms of its overall height. Like I could take a measurement of that and then compare that measurement to another. So I get that this should be basically half of that, which it is. So that's good. Trust me, it doesn't always happen that easily. All right, so I'm feeling pretty good. Notice that my first decisions were not all that right, but I'm getting there. Okay, next, let's take a look at the overall height of the box. And we're going to compare it to, okay, so this should be a little bit more than twice that. 1, 2, a little bit more, right about there. Buckle my shoe. Okay, so the height of the box should be about there. So I erred a little bit, made it a little bit too tall. Makes sense. Come back to the line. Now, one thing I know is that I know that this angle has to be a little bit more steep than that one, and vice versa. And I can test that premise. One way is just by extending lines. If I extend this line and I extend that line, I can see that right now these are diverging, and they should not be diverging, right? And similarly there and there, they are also diverging. And once again, they should not be diverging. In perspective systems, in perspective space, lines, parallel lines will converge. There is no divergence as things go back in space, right? There's, unlike evolution, it's just convergence. So, we can use that principle as a guide just simply by extending this and knowing that it has to at least slightly converge, that this angle has to be slightly more steep than that angle as a guide. But that doesn't necessarily give us a perfect, we don't know for certain, is that absolutely right? Another way to do it would be to measure what is the difference in height from like the front, from like this length to that back length there, right? Because they are actually not the same length. And okay, so I get that this is about, all right. That indicates to me that I'm accurate, that I maybe shifted that angle up, made it steeper just by a hair than it should have been. And what is this in relation to that? That's about right. So in this case, I'm making measurements, but I'm really only using my measurements in terms of proportional measurements. I'm using my measuring tool for angles, and I'm using my measuring tools to say overall what is the relationship between this line and that line, and then comparing them in terms of like while I'm holding my pencil out, and then comparing them on the page. Now I could certainly do a drawing where I just take a measurement and then build all measurements as like double that, right? Or triple that, right? And I could make a box. If I tripled my measurement, I could make a box that would be a little bit taller than this. It would have been, yeah, just a hair taller. So this is close to triple the measurement of the actual, what I'm actually seeing in the moment. Okay, I'm just double checking this distance and like that distance right there, just making sure that it matched what I was observing. Okay, so one box, but we actually have two boxes. So let's go ahead and put that one in. This one is much closer to straight on to us. And the first thing we have to determine is it perfectly straight on to us? I think it's just a little bit off. I can give you a reason as to why I'm guessing that. The reason why I think it's just a slight, very, very slight diagonal upwards right there is because I'm also looking at what I see in terms of the diagonals on the top of the box. And so this is much steeper than that. They're both angles a little bit, it's not so close to my eye level, like the middle of my vision on a vertical line would be right about here. Everything after that, if we were looking at a box straight in front of me, would start turning that way. These are just a little bit to the side of it, so my guess is that that box is just a hair on a diagonal away from me. And I made this, I have to adjust this, I made this a little bit too far away from that box. It should be a little closer. And I know that because as I was putting this angle in, it meant that I could see that back corner, and I know that I can't quite see that back corner. Let's talk about an extra special complication in this one, which is that the lid is on a slight curve, okay? The best way to deal with this is to start with the assumption that it's flat, because we could end just there, because we just say, that's the shape, and that is true to a degree. And then we could, if we want to, we could think about that slight curve of that top lid. We could actually measure it out, find where the middle of that plane is, and that would give us a guide as to where the top point, roughly, of that curved peak is. And we could then maybe design that curvature there like that. Okay, so that's the end of the cube demo. The last one will be on some more complex kind of bottle forms. All right, thanks. Oh,
Is that it?
we're done.